So if we can work alongside the plant intelligently in a kind way, then our chances of success are going to be that much more. The number of studies that are coming out now about nitrogen reduction through the use of nitrogen fixing microbes or phosphate reduction through the use of mycorrhizal fungi is staggering. And so I would encourage all of you to, if you haven't really looked into these types of crop inputs in the past, maybe give it a look, because there's a lot that other growers are achieving through the usage of these. Supplementing micronutrients precisely. This is another key layer in the apical method. And it's only goes without saying that, it's almost redundant. I shouldn't even have to say this, right? But at the end of the day, there's so much of this out there that happens that I felt the need that we had to really lay it out there in the method specifically, because how many times have you heard, well, you need some zinc, so we're going to put out a micropack, and that micropack has iron, manganese, and boron and zinc in it at different ratios and in different amounts. Then, if you look at a leaf or a soil analysis of that particular growing environment, and that growing environment may have a very high number of say manganese and boron, so then you're going to be applying more of what you don't need into a situation where you're trying to raise another nutrient. This is not going to work, and it's going to actually further antagonize the plant, yourself, your pocketbook, and lead you further away from your goals. And so this is a key component to why growth stage sampling of comparison, new leaf and old leaf, is so important, because when that growth stage hits, and the boron needs to triple because the plant has to start producing seed or pollen or another type of plant organ, or some sort of bud initiation needs to happen. If your plants are suffering and don't have that availability, immediately your yields are going to be affected. The sugar production is going to be affected. Long-term viability. The plant's going to have to cannibalize part of its own physiology from one plant organ in order to take to another plant organ to continue to survive. The process of plant cannibalism and its own self-cannibalism is rather discouraging, and it's continuous, right? And we don't see it a lot of times. Plants can take from one part of its own physiology to produce new seeds, new shoots, new growth, and often at the expense of long-term viability. This is one of the principles that you see in health decline of orchards and vineyards and so on that are going downhill. Using synergistic application sequences, this is another key layer. If you're going into a different stage of growth and you don't have necessarily all the nutrients that you need translocating from soil environment, which most of us don't, because most soils are relatively damaged and overstressed. If you can actually synergistically sequence your nutrients after one another, there's additional ROI benefits to be gained. So what do I mean by that? So one example would be, okay, we know we're going to apply a nitrogen fixing microbe to the soil. But if we know that all soils are going to be stressed with in the absence of soluble carbon, or some degree of carbon rich environment for those microbes to live in, if we don't have carbon in that environment, then the chances of those nitrogen fixers doing their job and making it worth our while to use them won't exist. So putting nitrogen fixing microbes after a carbon application would be one example of a synergistic application sequencing. You could take it one step further, where you use a carbon application, a nitrogen fixing microbe application, and then something to feed the nitrogen fixers themselves in order to make them replicate. So in this situation, it would be some sort of a microbial plant, a soil amendment of some sort or another. There's a lot of different ones out there, seaweeds and different herbal concoctions and ferments and so on and so forth. These would have the capability to actually feed the microbes as well. So you have basically taken a population of microbes, you've given them homes, and you've given them food, all simultaneously. And when doing so, you've now increased the success rate and increased the viability of that crop input, further reducing the need for additional layers of that same type of input, in this case, nitrogen. There's many different examples of this. A lot of them involve other micronutrients, using them synergistically, so such as applying molybdenum before a nitrogen application, or things like that. But there's a lot of different ways to sequence applications from data. Leveraging technology for efficiency. So if you're using the latest and greatest targeted sprayers, or low volume electrostatics, or aerial sprayers, or drone sprayers, or ground driven robots for liquid bands, all of these have applications that can help you potentially decrease your cost, decrease your labor, decrease the gallons per acre of water that you're using, increase your efficiency in the energy costs and usage of getting across the field, and so on and so forth. Technology is key in regenerative cropping systems. However, when not integrated fully with regenerative techniques, it can actually accelerate unwanted outcomes. There's a lot of examples of this over the last 40 to 70 years where we had a reasonably good technology, but it was overused or misused or used in the wrong way that caused an off-putting in one way or another on the environment, on humans, on animals, on soil microbes, on plants themselves, on just soil health, waterways, etc. When used properly, however, it's inspiring to consider what could be achieved when we utilize the appropriate technology for application and combined with smart data and really strong regenerative crop inputs. This is what we foundationally believe is going to move the needle into the next generation as the new paradigm progresses. And so that's the basic summary of the 10 steps of the Apical method, right? So if you start out with precision data and you finish with leverage technology, you've got a total package, 10 basic steps, unpacking them step by step in sequence for any crop, utilizing the applications as they come through the data portal. All of a sudden, you've got a system that you can make adjustments in real time in your crops with really great data, and know that what you're doing is actually going to improve your system and save you money. So before we launched our analysis methods and protocols and so on, this was kind of the state of the art. And to the folks that aren't continually sampling on a regular basis, they go right back here. It doesn't matter who you are, if you're not doing SAP analysis or some variant of it, you're going to end up here. You're going to end up guessing, and you're going to end up guessing along a very strange looking dream catcher that they call the Mulder's chart. The Mulder's chart's carbon is king. Thanks again very much, and look forward to seeing you all next week. Take care.